Welcome to Chapter 9, ladies and gentlemen. I'm so excited that you get to hear my lovely voice today. I know this isn't ideal, but it's our new normal, and we've kind of been set up for this, so algebra should go very similar to the way it's gone before. So working through the flipped classroom, and then we're going to be there on Tuesdays and Thursdays to help you out with questions. All right. In your packet, if you don't have your packet, I'm not supposed to encourage you to go up to school to get it, but please go up to school to get it because you're probably going to need it. It's going to be a lot easier. I did throw a couple of extra packets outside on the table outside in my classroom. So worst case scenario, if you don't have one, there are a few outside of Little's room on the other side. So there are some there if you don't have one in your packet. Otherwise, I'm also posting a copy of a PDF onto Google Classroom. That way you can work through that if you don't have it as well. So here we go. Quadratic function is a non-linear function. Okay, so this is what we need to write down. A non-linear function that can be written in standard form as this. Okay, so ax squared plus bx plus c. So this is going to be what we're working with a lot. And so moving on, what you're going to see is we've got these quadratic formulas, and they end up on the graph with this thing called a parabola. So a parabola is this shape. Okay, the parent function is just right here, which is not super necessary, but that's kind of what everything is based off of. You will know that there is an axis of symmetry, which is this blue line right here. The axis of symmetry cuts it in half. So it's symmetrical on both sides, which hence the term axis of symmetry, and it cuts the thing in half. And then there's the vertex, which is either the highest point or the lowest point of your parabola. Okay, so we're going to be talking today about graphing, and we're going to do how to graph an equation. So underneath in the box, you have some space to write this down. So how to graph it. So the first thing we're going to do is determine the vertex. This is super important that you write down. It's the opposite of b over 2a. So you're going to go through what each of those are. If there is no b, then it's just 0. Then we're going to make a table like we have before. We're going to plot 5 points. So the vertex is the middle number. Then we're going to do 2 numbers above it, and that should actually be 2 below. 2 numbers above and then 2 numbers below. So this vertex, the opposite of b over 2a, that's where we're going to start, and we're going to do 2 numbers above, 2 numbers below, and then we just plot the points and graph it. Sounds fairly simple. Okay. So I told you earlier that y equals ax squared plus bx plus c is the quadratic equation. And so what we need to do is this right here would represent the a. So if I have the opposite of b over 2a, I do not have a b, which just means that the b is going to be 0 over 2a, which would be 6. Well, 0 over 6 is just 0. So in order to set up my table, I need to put 0 in the middle, okay? I need to do 2 numbers above and 2 numbers below. So I have a -1 and a -2, and then 1 and 2, just like I've plotted before. So now what I need to do is I need to plug each of these numbers in for x. So 0 squared is 0 times 3 is still just 0. 1 squared is 1 times 3 is 3. 2 squared is 4 times 3, which is 12. Okay? So now I'm going to do my negatives. Well, -1 times a -1 is just a +1 times 3, which is 3. And a -2 times a -2 is a +4, which is 12. What you're going to see is these numbers will match. Okay? So let's plot those points. You are lucky enough to have points on your graph. I am going to pause this so I can get them. Okay, so I am going to go ahead and plot these points. So just like my ordered pairs, I've got a negative 2, 12. Now, it's going to be at the very top of the graph, and it's okay if it doesn't fit quite on there. You can estimate it a little bit. Negative 1, 3, 0, 0, 1, 3, and then 2, 12. Now, when you graph this, the line that you are actually creating is going to be a parabola, and you want to try to hit the best that you can all three of those points. Yes, I have a tool, I can do that, but you're going to try to do the best you can. It should look like a U. All right, so your domain, remember your domain is whatever you plug in for x, and so I can actually plug in any number I wanted to for x, so that would be all reals or infinite solutions. Because I'm going to get an answer out of it. And my range, in this case, what's happening, let's go ahead and close this down. What's happening with my range is that notice that it stops and everything is going to be above this line. So my range is going to be everything that y can be, and in this case, y is going to be greater than or equal to 0. So you're going to pick the number at where it stops, and then you have to pick if it's above or below. Okay, so this time it's a little bit different. This equation's a little bit different because I've got two terms. Okay, so I still have my ax, and I've got my ax squared plus bx plus c. So what I have here is, since it's squared, there's not really a number in front of it, so it's 1. So remember, we're doing the opposite of b over 2a. And then I don't have a b, but then my c is negative 5. So since I don't have a b, remember, it's just 0, which means my vertex is 0, which means that's my middle number. So I do, again, negative 1, negative 2, 1, and 2. It's really, really important that you're listening as we go through this, because it's going to be super beneficial for you as you're trying to take notes and understand this. Okay, so if I plug in 0, that would be 0 squared, which is just 0 times 1, so that would actually be a negative 5. So I'm going to plug in 1. 1 squared is 1 times 1 is 1 minus 5, so 1 minus 5 is a negative 4. A negative, I'm going to actually move up here to the negative 1. A negative 1 squared is 1 minus 5, which is also a negative 4. 2 squared is 4. 4 minus 5 would be a negative 1, which would mean that this is also going to be the same, because remember, we're getting mirror images here and here. That's a good way to determine if your vertex is actually correct. When you plug those in, you're going to see and make sure that they are correct. And if they are, then you know you've done your vertex correct. If they're not correct, that means that middle number that you started with is off. So you have to go back and check that. Okay, so let's just plot our points. So negative 2, negative 1, negative 1, negative 4, 0, negative 5, and then I've got mirror images over here. And I can do my parabola. Okay? Technically, you should also have little arrows on the end, because it does continue up forever and always. Domain. We're working through our domain. Domain is always all reals. And then my range, in this case, it's y. The point that we're stopping at here is negative 5. But it's going above, so y is everything greater than or equal to negative 5. Okay, it's going to be what that vertex is that's going to help you out. All right. Here we go. I'd like you actually to do this one on your own. Pause the video, try it on your own. Okay, now that you're unpaused, how did it go? This is what your graph should look like. You should have negative 2, negative 7, negative 1, 0, 1, 1, negative 1, and 2, negative 7. Your vertex, remember, is 0, so we did the opposite of b over 2a. We plugged that in and we got the 0 right there. And from there, that was, remember, our middle number. Domain is all reals. Range in this one is different because this one actually goes downhill, or like the parabola opens down, and it's because of this negative out front. That's why it's going down. And then whenever that happens, notice that I have less than 1 because it starts at 1 and it's everything less than 1. Okay, so this one's different because it's a fraction. Notice that there's no b, so I'm still going to do 0 out front. But since it is a fraction, I want to do multiples of 4. Well, this is squared. So I could do 4 and 8 and 12, but I'm actually going to do 2 and 4 and -2 and a -4 because I know that 2 squared is 4, so it's going to end up canceling it. Okay, so 2 squared, or 0 squared is 0, and times 1/4 is just 0 minus 3 was going to equal a -3. Okay, so if I do I do 2 squared, that's going to be 4. So what is 1/4 of 4? Well, that's just 1. So 1 minus 3 is going to be a -2. 4 squared is going to be 16. So 1/4 of 16. So that's 16 divided by 4, which is just 4 minus 3, which is, in this case, 1. Okay, so then moving to the negatives, my -2 squared is going to be 4. So 1/4 of 4, that's going to be 1. Minus 3, which is a -2, which means I know that this is going to match up as well. Okay, so if I went up by 1, I would end up with fractions in my answers, which is fine, but I know that you guys don't really like to use that, so that I try to avoid as much as I can. This time I'm going to go over 2. So make sure that you're plotting your points correctly, and then go over 4. This is a lot wider. So what you're going to notice is in the past we've had parabolas that are like kind of skinny and tall, and in this case it's going to be a lot wider, which means I'm going to have to adjust this guy a little bit. And messing this all up. And you're going to see that it's moving. Oh, maybe it's because I didn't put my point in the right spot. Come on, little. Okay. And so you're still going to be able to get it there. It's just going to be a little bit wider for you. Domain is still all reals. Moving down to, or infinite solutions. Moving down to my range, that point where it stops is going to be at -3. So y is everything greater than or equal to a -3. Okay, what's different here is there are 3 terms. This is going to be the last one I do with you, the last one you're going to do on your own. So A is right here. Remember, that's an imaginary 1. And this is B, and this is C. So I do the opposite of B over 2A. So in this case, it's going to be different because I need to make sure that I am working with those correct numbers. Well, the opposite of B would be a -4. Over 2 times 1. So that would be a -4 over 2, which is equal to a -2. That is my vertex. That goes in the middle. Now I do 2 numbers above and 2 numbers below. So if I do 2 numbers above and 2 numbers below, that would be a -1 and 0. This is going to be a little different because we're not starting with 0 this time, guys, okay? So this is where this is different. I'm still going to plug these in, except I've got a longer equation to plug it in this time. So let's do -2 squared, which is going to be 4, minus 8, because -2 times 4 is a -8, and then plus 7. So 4 minus 8 is a -4, plus 7 is going to give me 3. Okay, so on the next one, -1 squared is 1. And then it's going to be -4 plus 7. So 1 minus 4 is a -3 plus 7 is 4. And this is how I check it to make sure that I do have that vertex in the right spot, is I really do that -3. So -3 squared is going to be 9. That's going to be -12 plus 7. Well, 9 minus 12 is going to be a -3. -3 plus 7 is 4. These match up. You're good. That's awesome. So I've got 0 plus 0 plus 7 is 7. And here, oh, it's going to cut me off. I'm going to pause it. Check your answer. The last one's going to be on the Google form.